to Easy BTech. Today we will see one problem on total probability and Bayes theorem. So the given problem is like this. So this is called the binary symmetric channel. Binary symmetric channel. So in this problem they gave you P of B1, P of B2, P of A1 given B1, P of A2 given B1, P of A1 given B2 and P of A2 given B2. These four things they will give you. You have to find six things they gave you like this. So find they gave you that one. They want P of A1 and P of A2 and P of B1 given A1, P of B2 given A2 and P of B1 given A2 and finally P of B2 given A. So these six things we have to find using total probability and this one Bayes theorem. Now see, from the given figure we have six things: P of B1, P of B2, P of A1 given B1, A2 given B2, A2 given B2 and A1 given B2 and A2 given B1. So from the total probability we already know that what we already know, we know that P of A, is equal to summation P of A given Bn into P of Bn. So this is the formula we know. So we change this formula into like this. So in place of A, write A1. So it becomes P of A1 summation n equal to 1 to 2. Why 1 to 2? Because here they gave you B1 and B2. So 1 to 2. P of A1 given Bn into P of B. Yeah. So now I will expand this summation. Then it becomes P of A given B1. Sorry, A1 given B1 into P of B1 plus P of A1 given B2 into P of B. So after expanding the above expansion or the above summation, you will get like this: P of A1 given B1 into P of B1 and P of A1 given B2 into P of B2. So these are all four unknowns, but you can find out all these four unknowns from the above figure. So A1 given B1. So A1 given B1 is 0.9. So it is 0.9 into P of B1 equal to 0.1. Similarly, I want A1 given B2. So A1 given here, A1 given B2 equal to also, it is also equal to 0.1. So 0.1 into P of B2 is 0.9. So it is 0.09 plus 0.09 and finally it is equal to 0.18. 0.18 is the probability of P of A1. So this is the way you have to find out. So here to find the probability of A, we use total probability theorem. Similarly, the second one is what we have to find out is P of A2. So P of A2, similarly you can write like this: n equal to 1 to 2 from the total probability theorem. P of A2 given Bn into P of Bn. This is the same formula I am applying from total probability theorem. So what we will do, same, we will expand this expansion. So we will get P of A2 given B1 into P of B1 plus A2 given B2 into P of B2. So we can find out these four unknowns from the above figure. So what will do? P of A2 given A2 given B1 is equal to 0.1 and A2 given B2 is equal to 0.9. 0.9. So A2 given B1 equal to 0.1 into what is P of B1? We took in this problem 0.1. It is 0.1 plus A2 given B2 means 0.9 into 0.9. 0.9. So if you find out this one, what you will get? It is 0.01 plus 0.81. It is equal to 0.82. The probability of getting an event A2 is 0.8. So if you observe P of A1 and P of A2, so you will get 0.18 while calculating P of A1, and you will get what you get 0.82 in P of A2. So if you add this P of A1 and P of A2, what you will get? See here 0.82 plus 0.18, you will get 1. So that means the probability of events A1 and A2, sum of the probability of events A1 and A2 is equal to, always anywhere it is equal to 1. This you should remember while doing formula. So now P of A1 and P of A2 are over. Now I am going to calculate P of B1 given A1. B1 given A1. So we already know that from the base theorem, P of Bn given A is equal to P of A given Bn into P of Bn divided by P of A divided by P of A. Now change this n to 1. So n means P of B1 and A2 A1. What you will get? The formula changes like this: P of A1 given B1 into P of B1 divided by P of A1. This is the formula to find out P of B1 given A1. So A1 given B1, we already know A1 given B1. What is the value of A1 given B1? So the formula, the value of A1 given B1 is equal to, it is equal to 0.9. So 0.9, that is, it is equal to 0.9 into B1 is equal to, we take 0.1, and we have already calculated P of A1. So the value of P of A1 equals 0.18. So it is equal to 0.09 divided by 0.18. That means it is 1 by 2. So the B1 given A1 is equal to 0.09 divided by 0.18. I got. So the value of this B1 given A1 equal to, so 1 by 2. So basically I am changing the base theorem into our known forms. Known forms means here it is in terms of n and in terms of a. But I will change this one in like this. So in place of n, I will put n equal to 1. I will take 1 equal to 1 and I will change a equal to a1. So then then the formula is like this. So it changes to a1 given b1 into p of b1 divided by p of a1. So in this way you find out the P of A1 given B1. Similarly, if you want P of B1 given A2, B1 given A2. This is also same formula. B1 given A2 equal to P of A2 given B1 into P of B1 divided by P of A2. P of A2. So in this way you will find out this one. So what is the value of P of A2 given B1? So P of A2 given B1 is equal to, see here, the A2 given B1 equal to 0.1. 0.1. So what you will write? 0.1 into P of B2, you take 0.9, and P of A2 we already calculated, it is 0.8. This means it is 9 by 82. So 9 by 82 is the probability of B1 given 8. B1 given 8. So similarly, I want next things. So you completed in the numerator, you completed See here, you completed in the numerator b1, both the b1s, and combined with a1, a2. Now I will take b2. I will take b2. So if you take b2, so b2 given a1 is equal to p of a1 given b2, a1 given b2 into p of b2 divided by p of a1. P of a1. This is the formula to find out the p of b2 given a1. So just changing the formulas to known forms. So we already know p of a1 equal to 0.18, and p of bt equal to 0.9. And what is this a1 given b2? So I got a1 given b2 is equal to, so 0.1. 0.1. So that means it becomes 9 by 18. So the value of this one is equal to 1 by 2. 1 by, okay. Now in the final thing, what is you have to find out? P of b2 given a2. b2 given a2. So answer is like this. A2, the formula is like this. a2 given b2 into p of b2 divided by p of a2. p of a2. So we already know the formula for p of a2, and value of p of a2, it is 0.82, and p of bt is equal to 0.9. And what is p of a2 given b2? a2 given b2 is equal to also 0.9. So answer is 81 by 82. Answer is 81 by 82. So this is the way you have to calculate all the given things, all the asked things using the Bayes theorem and total probability theorem. So this is the one of the example of example problem how to apply your formulas, this total probability theorem and Bayes theorem formulas in the given of by using the given problem. Okay, so the problem is very easy. So but you need to know how to change the given total probability theorem. Then only you can able to find out. You can able to find out the asked things, that is p of a1, p of a2, p of a1 given b1, a2 given b1, b1 given a2, or like this anything you can find out. You can apply the formula, you can change the formula into your known forms. Then you can able to calculate the probabilities. So this is one of the important problem asked in your exams. So prepare, study the problem very well. What are the things they gave you? What are the note down all the probabilities. Afterwards, think how to do problem. Afterwards, how to do. You have to think how to do the problem. So now the next topic is independent events. So the next topic is independent independent events. Independent events. So the name comes from like this. So if you take two events like that, is if you take two events a comma b, I am taking a comma b or s, are two events. And if you want p of a intersection b of these two events. So the independent events means the P of A intersection B for any two independent E is always equal to P of A into P of B. That means independent means the probability of one event is not depend on the probability of another event. So they are individual. So that's why they are called independent events. So whenever if you want to find out the independent events, you have to know this one. Suppose they gave you it is 1 by 4. It is 1 by 4 P of A intersection B. If it is 1 by 2, it is also 1 by 2. Then 1 by 2 into 1 by 2 is equal to 1 by 4. So I can say that A and B are independent events. So if it is not one, if it's not equal to given thing, suppose they gave you 1 by 8, and after finding out you will get 1 by 4 into 1 by 4. Sorry, 1 by 2 into 1 by 2 is equal to 1 by 4 is not equal to 1 by 8. Then I can say that the events are not independent or dependent events, like that. So to find whether the events are independent or dependent events, you have to check this formula. and you should know this equation must be satisfied. This equation must be satisfied. Okay, so that is what about independent events. So suppose the independent, it is the independent events formula. Here I am telling about only two events. Even I told about the only two events. Suppose the number of events are more, that means there are number of events a1, a2, a3, and so on, an. So there are n number of events. So what is the formula for independent events? If all the, I mean, I can say what all are independent events, then the formula is a1 intersection a2 intersection a3 and so on intersection an is equal to, so the independent events probability is equal to, so same formula you have to apply, p of a1 into p of a2 into p of a3 and so on p of an, p of an. So this is the formula. So this is for multiple events, multiple multiple number of events. So your my multiple events are a1 comma a2 comma a3 comma and so on an are the events. So if I want to say that these events are independent events, these events must satisfy this formula, that is P of a1 intersection a2 intersection a3 and so on intersection an is equal to their individual product probabilities. So the individual products probabilities are, the probabilities P of a1 into P of a2 into P of a3 and so on P of a and so on P of an. So if these conditions are satisfied, then in that case the events are called what? Independent events. So in the similarly, we already know that when the events are said to be mutual exclusive events, in the same way, mutual exclusive means you have to know P of A given B is equal to 0. In that case, you know the events are what? Mutually exclusive events. Mutually exclusive events. So if P of A intersection B is equal to P of A into P of B, P of V, then the events are called independent events. You should remember this difference between them, independent and mutually exclusive. So independent means that is a product, mutually exclusive means that is zero. That is zero. So this you should remember. Now the properties of independent events. Properties of independent events. So how the properties will be defined? We will see here. We'll see here. The properties, there are two properties. The first one is p of a1 intersection a2 intersection of a3, p of a1 intersection a3 intersection of a3. So that it is like given like this, p of a1. So wherever you are having intersection, you should make it is as product p of a1 into, first it is p of a1 into p of a2 intersection a3. Afterwards remove second intersection, then it becomes p of a1 into p of, it becomes p of a2 into p of a3, p of a. So this is the first property of this independent events. Now the second property is if ever there is a union, that is a1 intersection a2 union a3. Okay, so in this case how you should written, how you will be written is, so here intersection is there, no? So whenever intersection there, you make intersection as product p of a1 into, and write second thing is as it is p of a2 union e3, a2 union e3. And here if you see, there is no intersection, here you are having only union. So if ever union intersection only, you make it as product, but here it is union, no? So you should not change anything, you should write like that only, so same as it is. So that it is here, it is p of a1 intersection a2 union a3 is equal to p of a1 into p of a2 union a3. And if ever all the intersections are there, all are intersections, then it is a1 intersection a2 intersection a3, then it is a1 into a2 into a3. So these are the two properties of your independent events. So we'll see one problem on independent events. After that we'll go move on to next topic. So that is in the problem. What is the problem? So the problem statement. So we'll see one problem on independent events. So see this problem. In an experiment, one card is selected from an ordinary 52 card deck. Define events A as select a king, B as select a jack or queen, and C as select a heart. Select a heart. These three events are defined. So we want first find out the probabilities of individual events. So to find out the probability of individual events. So first the event is P of A. So we have to find out the probability of event A. So select a king. So actually, if you see the card deck, so there are totally four king cards. So out of four cards, you have to take one. So that is 4 by 52 is the probability of getting a king. Getting a king. So now see, next one is P of B. P of B. P of B. So probability of getting select a jack or a queen. So totally there are four jacks and four queens, four jacks and four queens. So the probability of getting jacks is 4 by 52. Here R means here they say R means there may be chance of getting Q also, that is 4 by 52 plus 4 by 52, it is 8 by 52. Why? Because here plus is coming, they told you R means jack or king. You can get jack either or queen. So that is 8 by 52. Now the probability of P of C. So P of C is equal to select a heart. So how many total heart cards there? So hearts totally 13 cards. So the probability is 13 by 52. 13 by 52. Now we will check whether A, B, C are independent events or not. Now check what I have to do is whether check P of A intersection B is equal to P of A into B or not. P of A into B or not. Now intersection means what? Intersection means what? See here. So the first one is events is select a king. B is select a jack or queen. Intersection means that card should be and here intersection means and. That card should be king and jack or king and queen. So intersection means, see clearly, intersection means it should be king and jack. So and means that card should be both. That means there is no chance of intersection here. So that is it is 0. It is 0, but it is 4 by 52 into 8 by 52. So it is not equal to 0. That's why A and B are not independent events. Not independent events. So that you should understand. Why not be independent events? From the events we have calculated P of A intersection B. How P of A intersection B? It is A is select a king, B is select a jack or queen. So intersection means and means king and jack. That single card does not always shows jack and king at a time. So it might be king, it might be jack, but not both at a time. So that's why P of A intersection B is not valid. It is equal to 0. And we already know P of A and P of B, and it is like this. It is like this. First one. Now second one is, what is the second one? What is the second one is P of B intersection C. B intersection C means jack or queen, jack or queen, and heart and heart and heart. So now see, in the heart there are 13 cards. There are 13 cards. There are 13 cards. In that 13 cards, one jack and one queen will be there. One jack and one queen will be there. So if you intersection these both things, two cards will be matched. Two cards will be matched. That is here also J and Q, and here also you are having one J card and one Q card. So two cards will be matched. No, that's why the probability P of B intersection C is equal to is equal, two cards will be matched out of any how many, 2 by 52. 2 by 52. So we know that P of B intersection B equal to 2 by 52, and what we know, P of B equal to 8 by 52 and P of C equal to 13 by 52. We have to check it is equal to 2 by 52 and 8 by 52 into 13 by 52. 2. Now if you see 13 fours 52 and 4 twos, it is also equal to 2 by 52, and we can say that is 2 by 52 is equal to same answer. You'll get after producting the p of b into p of c, you'll get the same answer. So I can say that b and c are what? Independent events. B and c are independent events. So what I am doing here, I am just verifying the formula. Known, I mean, I have find out the p of b intersection c, and I will make the product on the right side. If both are equal, then I can say that independent. Otherwise, I say that they are dependent events. So the final thing, what? A intersection b over b intersection c over, and I will say c intersection a. So c means I will write p of probability of getting heart and heart and king, heart and king. So here there are 13 cards. King means 4 kings. But out of 4 kings, one is heart king. Here also you are having one heart king. So one heart king match means the probability of B of C intersection A is equal to 1 match out of 52. It is P of A intersection C. So now I have to verify this one is whether it is equal to P of C into P of A or not. We already know that P of C equal to 13 by 52, and we already know that P of A equal 1 equal to 4 by 52. So 4 13s and 13, so which is also equal to 1 by 52. Now similarly I can say that A and, so this is equal. See here 1 by 52 equal to 1 by 52, you get the same answer. So I can say that A and C are what? Independent events. So finally I can conclude like that. So you have three events, A, B, C. Okay, A, B, C. So in this, A and B are dependent events. We can also call that A and B are mutually exclusive events. Why? Because you say A intersection B equal to 0, mutually exclusive events. And B and C are independent. Events. And C and A are also independent events. So these are the three conclusions we have find out from the given formula. We should verify like that to find whether the given events are independent or not. So you should know only one formula. Intersection P of A intersection B is equal to P of A into B or not. You should verify only one formula. With that, you can calculate different probabilities. So this is what about independent events. So we can see these independent. You can also see here, find whether A, and that means three events. You take P of A intersection B intersection C. Whether A, B, C combined together independent or not, we can say that no. Why? Because we already say that A and B are not independent. So I can say that A, B, C combinedly are not dependent events. Combinedly, they can say that they are independent, not dependent, not independent. Or else you can say that A, B, C are mutually exclusive events also. Why? Because the probability P of A intersection B intersection C is equal to here what it is 0. So combinedly you can find out the independency for multiple events also. So here it is mutually exclusive. So combinedly three events. So this is the way you have to calculate the events independence. So with this I will conclude today's topic. So we'll see in the next class about random variable. Thank you. So all of you please subscribe to Easy B Tech.